Welcome to the chapter on geologic time. Sorry, I'm resetting my clock here so I don't run over. This may take 2, maybe 3, heck, maybe even 4 sections, but I think you'll like it. I love this area. Okay, I know I say that about everything, but I really like geologic history. To me, it's like a puzzle. You know this is basalt up here, but what came before the basalt? If you go in there and look at it, you can figure it out, and you can figure out the history of this area. And knowing the history, you can appreciate how long this area took to create, and I think knowing that, you tend to take better care of the earth. Just like when you know about your family history, you appreciate your grandma, grandpa, aunts, and uncles better. I feel the same way about the earth. I know it's a little weird, but that's the way I am. Let me take the microphone out because we're going to the next slide.
Exxon paleontologists call for increased U.S. fossil production. It's the Onion Radio News. I'm Doyle Redland. A team of Exxon scientists released a report today calling for an immediate and substantial increase in U.S. fossils.
At the current rate at which we are producing new fossils in this country, we will not have enough to meet our fossil fuel needs for another 12 to 1,500 million years.
Dr. Jameson Lamb, Exxon urged Congress to establish incentives for the world's plants and animals to decay, sink deep into the Earth's crust, and fossilize no later than July. Doyle Redland for the Onion Radio News, online at theonion.com.
Okay, some early determinations of Earth's age. This is early work by James Hutton. What you're looking at here is a version today of what he saw a long time ago, back in the 1800s, 1700s, I think. You can look it up. I can't remember that stuff. And people had said up until that time, Earth was created about 4,000 BC, 6,000 years ago. And Hutton looked at these rocks and thought, something's wrong here. These are sedimentary rocks. You already know that sedimentary rocks form horizontally. So if that's the case, these had to form horizontally and then get tilted up. And then take a look. They've been shaved off. So that means they had to get eroded down. And then you have a whole bunch of sediments on top of here, loose stuff. And then this is limestone, which occurs only in a shallow sea. So this area had to be under an ocean. And then since that time, it's been pushed back out of the land again, and you have stuff on top. Hutton reasoned this had to be really old. And no matter where he looked around the world, this kind of thing was going on. Take a look. Right here, you have some extremely old rocks that are tilted this way. They had to be deep under the ground in order for them to form. Then they had to be lifted up, close to the surface, shaved off, so there's an unconformity here. And then sedimentary rocks were deposited on top of them. Then this whole thing was twisted a little bit and lifted out of the ocean. Which takes a long time. This is a cool quote from James Hutton. And if you want, you can stop and read it. I don't want to read it to you. There are better things to do with our time, but I'll still be here when you unpause. Some observations. Lord Kelvin, a British geologist, figured that the Earth was somewhere around 20 to 100 million years old. He was a little bit off, but that wasn't bad for back then. By the way, Lord Kelvin's real name was Bill Thompson. I have no idea how he got to be named Lord Kelvin. It happens in the British aristocracy. Uniformitarianism. This is the idea that what goes on today goes on in the past. For example, if you see water settling into the bottom of a river and it contains sediments, and those sediments stack up horizontally, it's pretty much the same thing that happened before. If you see lava flow out of a volcano and flow on top of previous lava flows, stacking up layer after layer, that's probably what happened before. It's not an earth-shaking idea, no pun intended, but to a lot of people, they never considered that before. They thought the Earth was just this way. And it probably got this way because step by step by step, and because we're so short-lived, we don't even think about this. Here is a series of lava flows in, where is this? On the island of Kauai. There's a little rental car I had. And if you've looked at lava flows go out, they go out inch by inch, foot by foot. This cliff is probably 600 feet high. How long do you think this took to create? It was not a very fast thing. And then on top of that, how long do you think it took for this to wear down? Here is a view of a neighboring island. That was on Kauai. This is Hawaii, the big island. And what we look at here are layers of lava flows, older flows, younger flows, younger flows. You can start dating things. The black rock that's here, it's older than the rock that is now flowing on top of it. And this will go on year after year, creating stuff like this over time. This is, gotta remember where I took this, somewhere near Los Alamos, but I'm not sure. These are layers of ash from a volcano, layer after layer after layer. This takes an incredibly long time to form and then to break back down. Okay, we do that a lot more quickly. Archbishop Usher back in the 1600s decided that the world was about, created, let's see, at 4004 BC, Sunday, October 23rd, 4004. But he did it by looking at begats in the Bible. There probably are some other things that we could look at that might be a little bit more data-based. Hindus, by the way, thought that the earth was created 1,972,942,112 years ago as of 2011. So this is 2000, whatever it is. So add a few years to this. Let's look at relative time. First, let's go here. It appears that the Earth, oops, let's go back to 1. I have no idea why I went there. It appears that the Earth is really old. There is a lot of history that we can look at. If we'd write a history of Earth's past, allowing just 1 page per year, the book would be about 4,600,000,000 pages long. How thick of a book would that be? About 145 miles. Would not want to read that book. An average reader, reading about a page every 2 minutes, would need about 17,503 years to finish the book. And that's continuous reading. If you're a speed reader, you could read 2 pages a second. Don't ask me how. It would take you 73 years to read the book. So let's break it down to something more manageable. If each page contains 10,000 years of Earth history, the book will only be 460,000 pages long. It'll take a speed reader just 2 2/3 days of nonstop reading to complete it at 2 pages per second. Let's look at some of the things that have happened in Earth history. There, the formation of the Earth and the Moon, about 4.6 billion years ago. Here, the earliest life that we know of, found in the fossil record, 3.9 billion years ago. About 420 million years ago, the first land plants. Major mass extinction about 248 million years ago. Dinos died out about 65 million years ago. The first humans, or human-like animals, about 4 million years ago. Now I'm going to go back to the presentation because I don't want to spend too much time on this. You can do that. You know about relative time. Relative time is just putting things in order from youngest to oldest, or in this case, in geology, did I say that right? We're going to go oldest to youngest. Now, relative time does not have to do with my relatives, and no, these aren't my relatives. But let's put these in order from oldest to youngest. I would go with this guy, this lady, and this cute little baby. Poke, poke, poke. Oh, he's so cute. Old, medium, young. Do we know how old they are? No, but we know the order in which they occur. We can do the same thing with vehicles. Oldest, medium, my car. Okay, probably not, I'm a teacher. Let's try it with this stuff. We've got pictures of an island with a fringing reef, a coral atoll, a barrier reef, an island with medium vegetation, freshly cooled lava, heavy vegetation, minor vegetation, and erupting lava. We could put these pictures in order. Let's look at them closely. Here's the fringing reef. By the way, this is the island of Moorea in Tahiti, or French Polynesia. I spent a lot of time here a long time ago helping a Tahitian family harvest coconuts and pineapples and killing a pig for Bon Ani, New Year's. I had tried to swim out to this island. Not my best idea. I couldn't see this from the satellite view, but all the water that comes up on this reef, in this area, goes out this ava, or break in the reef here. So as I was trying to swim over here, all the water is going against me. If I had been smart, I would have started over here and swum out to the island. Then when I was done, I could have just kind of come down here and gotten back on the mainland. So, Moorea, fringing reef. Here's the island, here's the reef out here. This takes a while to form. Usually the reef is right next to the island. Here's a coral atoll. Here's a barrier reef. Notice how far out that is. Here is medium vegetation on the big island of Hawaii. Here's heavy vegetation. Here is freshly cooled lava. Minor vegetation. Erupting lava. So, put these in order. Go ahead and pause now if you want and see what you can do. I am going to move ahead and keep going, but you can pause and see if you can put these in order. Okay, I'm picking it back up. Here is the correct order. Once the volcano comes out of the water, if we're looking at islands, you have erupting lava. The island can take millions of years to form. We're watching this go on with Hawaii now. Here's freshly cooled lava. Once the lava has cooled for a while, you get some minor vegetation, things like the ama'u fern, the haleama'u fern, and I forget some of the other plants, are the first to go in there. Then medium vegetation, and then heavy vegetation, and then an island that is getting worn down, and you get a fringing reef. Right here, the reef is right next to the island. And then you get an atoll, and then you get this barrier reef in which only little pieces of the island are protected inside this barrier reef. This is an incredibly long process. I just like this sign. Don't steal rocks, and if you do, the rocks will get you back. Okay, we put people in order, we put cars in order, and we just put island history in order. Can we put something like this in order? What is the oldest formation in here? Well, I think it's kind of obvious that the last formation is probably the Skinner Gulch limestone. Skinner! And after it was formed, whatever happened, this was raised up, and you have a canyon going through here. So you've got a canyon, you've got this being raised up, you've got limestone deposited in the shallow sea, you've got the Hamlinville Formation, which looks like sandstone, so it had to be probably shallower than the limestone. You've got shale, which is even shallower. You've got a mess here, which is a combination of shale and sandstone. But we're going to go through this step by step. We don't need to learn it all right now. Let's start easier. Let's look at A. Which is older, sandstone or shale? Obvious answer. Shale got deposited first, and then it looks like it got worn down, so it's been eroded. So that means this was out of the water, and then it got plunged back under the water, and sand deposited on top, and sandstone. B can be a little tricky, but if we're taking this simple approach, it looks like granite was there first, it was worn down, and then sandstone on top. It's getting even trickier. You have several layers here, sandstone, shale. They were probably laid down horizontally, then they were tilted up, and they were shaved off by something. The big shaver of geology. Time, erosion. Leaving this unconformity or uneven surface. This indicates missing time, and then sandstone was stuck on top of here. This is a really long history going on. And then this one, what happened first? Were the layers deposited first, or was this fault first? Those of you who are thinking, the layers had to be there first before the fault came along. I'm going to pause here, and we will come back and try and solve this one.